Hey YouTubers, welcome back to my channel, or if you're a new viewer, if you're new to my channel, welcome. Today I am going to discuss a data structure called a linked list. Okay, so why do we use it? Why is it helpful? How does it work? Let's see. Suppose you had an array. Alright, we have an array here, very common, and it starts at index 0 all the way up to index I. Now, as we know, arrays are they take up a contiguous block of space in memory. And the thing about arrays are they cannot grow and they cannot shrink. So what does that mean? That means that a programmer has to have a pretty good idea of the size of the number of entries the array would consist of prior to allocating this contiguous block of memory, which is kind of unrealistic because suppose you create an array of size 1,000, right? And let's say you find out later down in the program that you need an array of size 100,000. Well, what you have to do at that point is allocate a space for a new array and copy the contents of the old array into the new array so that you have a space for more elements to add. Now, that's kind of, inefficient, cumbersome, and tedious to do, and this is exactly where linked lists come in. So let's talk about linked lists. Okay, let's change colors. I don't like that color. Let's go with green. Why not? My favorite color. Okay, so linked lists are the space for the linked lists are allocated on demand. Okay, they're allocated in a unit of space called a node. And I will talk about what this node is. Okay, so when you allocate space for a node, unlike the arrays, which is contiguous block of space in memory, nodes they can be anywhere in memory. So what that means is that any new node that you create is unrelated to any previous node. So let me write that down. So any new node created, this is important, is unrelated to any previous node. I know my handwriting sucks. So how do we create a linked list? Because after all, it is a list. Well, since they can be anywhere in memory, we use a mechanism called linking. Linking. Okay, hence linked list. And this brings me to a point to explain what a node is. So, like any data structure, you need a way to store data and have a way to refer to the next element in the data structure. In this case, we use the mechanism called linking, and to graphically represent a node. Let me change colors one more time. Let's go with orange. Okay, so this is what a node is graphically. We have two parts inside a node. This is a data section. Oh, well, it's not clear enough. So this right here is a data section, and this is a link section, which will hold a reference to next node or previous node, whatever. Okay, so this is just this part of the node is a way to refer to the next node. Since they can be anywhere in memory, this is a way to reference next node in the list. Okay, so this is a part 1 of the tutorial. Okay, and part 2 will consist of how to add nodes to the list. Oops. Okay, so thank you for watching. I hope this was helpful, and tune in to the next part to find out how to add nodes to the list. And we're also going to create lists and the 3 ways to add nodes to the list, and we're going to go over all of them. Thank you for watching.